In this video, we're going to look at histograms and how they actually represent data visually once we've had it taken from our frequency table here. So we've got our frequency table that we use to look at our shoe size. We've got all our shoe sizes down here, and we did all our tallies to get our frequency numbers. Now, a frequency histogram pretty much just looks like a bar graph, but we've got a few small changes that we need to make. So frequency is always going to sit on that y-axis. That is always going to be there. It doesn't matter what kind of data we have on the x-axis running this way, it is always going to be a frequency histogram, and frequency is going to be what we're measuring. So to start off with, this might be all you have. You might just have your x-axis and your y-axis, and you need to start putting shoe size down here. So you will need to write what this data is. Shoe size, we didn't really have like centimeters or anything like that this time, but in future we might, so you'll have to be careful of that. All right, our shoe size, we are going to have 8, 9, 10, 11, 12, will we fit them? 13, 14, just barely, right? We'll have to make it stretch for now. That's okay. Because in this case, our data belongs only to here, only to the size 8 shoe, it's a discrete value, then we are going to have to draw our little bars that relate to it, and we're going to do it on top of it. So we have frequencies that really only go up to 3, so we can start obviously down here will be the 0, 1, 2, 3. You might in future need to go a lot higher, but today we don't really need to. Okay, first one is shoe size 8, and it has 2. So here is our 2 frequency, and here is our bar. I'm going to just color these in so you can see. All right, same thing here with the 9. Okay, the 9 also has a frequency of 2, so that's our next bar. Obviously, I would use a ruler if I was doing this on the paper. Same thing with 10. 10 is going to be 2. Okay, 11 also 2. All right, very consistent so far. We have a shoe size of 12 down here. We only have 1 of them. We have 3 in the 13 though, so I would have to get my ruler out and measure up to the 3. Ooh, got a bit on there. That's okay. We can erase some of that. There we go. And we are up to 14. There are none in 14, so we don't have to draw any bar. And in 15, we once again have the 1. So we will include that there. Right, so there's our frequency histogram. It's not particularly fancy, but it does display visually the information that we need. You would also need a title. So our title will be shoe size in 9 maths, whatever it is your title will be. Now, if we have a look up here, what we've got is 4 kinds of ways our data can be spread. It can be symmetrical. It can go all the way up and come all the way back down again. It might be symmetrical by scooping underneath and going up as well. A negative skew means it's kind of skewed towards those back end or those higher numbers, whereas a positive skew means it is going to heavily favor those numbers or higher frequency at those numbers which are smaller. Bimodal data means it has 2 peaks. We don't really have 2 peaks here. We kind of have a nice flat plateau here. So our data in this case doesn't really represent any of those types. So if you're asked to describe the skew of that data, right, skew meaning how it is shaped, then we really don't fit into any of these this time, okay? Some important points about a histogram. The bars always touch, always. There is no exception. It is not a bar graph. This is a bit different, remembering that it is a frequency histogram. So the way that we do a frequency histogram is the bars will touch. If, for example, you are going to have to draw a histogram where you're talking about height and our categories are going to be, say, 150 to 155, instead of actually drawing the bar on top of the section down here on your scale, if you had a section of 150 to 155, you would actually draw the bar in here. Okay, it wouldn't be that messy, and so on like that. So you'd have to draw your bars between the scale points there. So you'll come across some of those. It might be that we're looking at our height data and we've done it in groups of 150 to 154, and you go all the way up to where you've got that part in the scale.